April showers bring May flowers, and as gardeners, we anticipate any rainfall that we might get. Have you ever heard on the news that we got a significant rainfall, or perhaps you've seen in your rain gauge that there was some good rainfall, only to go out into the landscape, pull back the mulch, and find some dry areas still? When the rain is falling from the sky, we just assume that it's going to reach the ground. But is it any wonder that when we're putting ground covers down and mulches down to prevent evaporation and water loss up out of the soil, that when the cycle is reversed, we also have obstructions that prevent the rainfall from penetrating down into the ground? This is known as rainfall interception. Rainfall interception is when rain is prevented from reaching the soil because it is intercepted by plant canopies or plant residue and then eventually evaporates before coming into contact with the soil. Now there's a couple of ways this can occur, but first of all, not all the rainfall is blocked by the canopy. This is known as throughfall. Throughfall is the term used to describe the rain that passes through the canopy of the plant. However, the rainfall still may land on plant debris or mulch, preventing that rainfall from penetrating down into the soil. You can also see this in your home landscape sometime when you've ran your irrigation system for a period of time, only to go back into your landscape and pull back the mulch to find that there still is not moisture down in the soil. For the rainfall that does come into contact with the plant, two things can happen. Stem flow describes the rain that hits the plant canopy and, aided by gravity, travels down the leaves to the branches and eventually to the stem or the trunk of the plant. At this point, the rainfall can still be intercepted by plant debris at the base of that plant. However, some rainfall will actually be able to penetrate down into the ground as it follows the trunk of the tree. Regardless, stem flow does influence rainfall distribution. Meanwhile, some raindrops roll off the canopy of a plant like water rolling off the shingles of a roof. In fact, the outermost distance of a tree's canopy is called the drip line. Think of it like how the water drips off an umbrella. This can result in more water being redirected to the drip line than other areas. This rainfall interception is called the canopy drip. While this occurs in nature, keep in mind that this can also occur with irrigation in a home landscape, especially pop-up or spray heads that shoot the water horizontally. As plants grow, they can block the irrigation from traveling to the intended distance, causing more water to fall around the base of one plant and prevent other plants from receiving adequate moisture. There are two components at play with rainfall interception. That is the vegetation and the rainfall. Let's first talk about the vegetation. Plants come in all shapes and forms and have adaptations in order to survive in their ideal climate. Orchids are a classic example. Many orchids are epiphytic. An epiphyte is a plant that does not grow in soil. Instead, it grows by clinging to another plant, often a tree. Epiphytic orchids have large root systems, not only to help anchor them in the tree, but also provide greater surface area to absorb rain that is often flowing down the tree through stem flow. Not only do orchids take advantage of the stem flow coming down the tree, they often have a V-shaped branching habit, creating their own stem flow that directs rainfall towards their roots. We can also see this in bromeliads that form a cup with their vegetation. This equips the plant to be able to selfishly store water, allowing it to endure drier periods and giving it a competitive advantage over other plants. Now you may be thinking, these are tropical plants that live in the rainforest, but rainfall interception happens everywhere. In fact, it's been reported that the rainfall interception rate in the Amazon rainforest is at 9%, while under eastern red cedars it's at 36%, and a whopping 44% in the tall grass prairie. Another plant adaptation is the surface of the vegetation. Many plants are pubescent, meaning that they have fine hairs either on the surface of the leaves or along the stems. And these hairs actually serve a purpose and capture some of that moisture, retaining it for the plant a little bit longer. The second factor to consider is the rain itself. A rain event is described by the amount, the intensity, and the duration. This should also be considered when setting up your irrigation. Irrigation systems that are too brief or have nozzles that spray fine droplets will often result in having more water loss due to evaporation and also will create more water particles settling on the vegetation. So, does vegetation influence rainfall distribution? Yes. Does it prevent some rainfall from actually penetrating down into the soil profile? Yes. However, that vegetation also serves a critical component and acts as a shield protecting our soil. It not only takes the impact from the raindrops, but it also reduces soil loss and soil erosion. So the next time you look at your rain gauge and you see that you get an inch of rain, just know that not all rain is created the same.